We do all kinds of things with our computers. We watch movies, we play games, we listen to music. We might just work on text documents. Sometimes we might do very simple things like adding and dividing numbers. And you know that at the most fundamental level, computers only understand ones and zeros. So there has to be a way to convert movies and photos and all of these things into ones and zeros that the computer understands, and the computer can process these things. So this process is called encoding. But encoding alone is not good enough, because you might convert a photograph into ones and zeros and change the ones and zeros, but until you convert it back into the original form, you won't be able to tell what changes were made. So maybe you might have increased the brightness and you won't see that difference until it's changed back from ones and zeros into a photo. So that second process is called decoding. So encoding is converting from a form that we understand into the form that computers understand, and then decoding is converting it back into the original form. So as you can guess, because everything's stored in ones as ones and zeros, the computer can't differentiate different types of uh, data unless we tell the computer what those things are meant to be. So along with the data, we also need to store or specify the data type, and only then the encoding and the decoding can take place in a meaningful way. So that's where data types come into play. Now let's take this very simple binary number sequence. We have 1, 5 zeros, and 1. So there are 7 digits. And just this little number can be decoded as a whole lot of different things. It can be decoded as decimal 65, the whole number 65, we call it an integer. It can be decoded as 1.4013 divided by 10 to the power 39, which is a number with a decimal point, and there's a whole lot of zeros after the decimal point. And it can be interpreted as the character uppercase A. We sometimes just call it a char for character for short. And it can also be a shade of gray. Now, this is a very dark shade of gray, and you might not notice it, but that's also from this same sequence of binary digits. So that's the bad news. The programmer has to choose the data type for the data that they are encoding and decoding. And you have to do it for every piece of information that you process. And the good news is you don't need to deal with binary. It's far easier to mention the data type, saying it's a whole number or a character or something else. That's a lot easier than dealing with ones and zeros. So, and the computer takes care of the encoding and the decoding for us. We just need to specify the data type. Now, most programming languages have built-in support for certain data types, and they're called primitive data types, and they are a part of the language itself. Now, in addition to these primitive data types, you get custom data types that come as a part of collection when you install the programming language. So you get these additional libraries of code, and you get custom data types in those. So we call them non-primitive data types. The best analogy that I can think of is, if you're studying English, you have the words that are valid in English. A dictionary might define them, and then there are grammar rules, and that sets the core language, right? And at the same time, there are very important literary works like Shakespeare that uh, they are very closely related to the language. You can't separate the two, right? Because if you're studying one, you have to sort of study the other, or at least you come across the other. So that's That's a very similar relationship to what you have with primitive data types and non-primitive data types. Now in Java, there are 8 primitive data types. There's byte, short, int, long, float, double, boolean, and char. So byte, short, int, long, they are for whole numbers. Float and double, they are for numbers with decimal points. Boolean is for true or false values, and char is for characters. So that's short for character. If you want to look at the details of this, you can go to this link here and you can read all about them. But I don't recommend you to do that right now itself. You can do that after this lesson because there are lots of details there which you don't need to know right away. So in addition to the primitive data types, there are non-primitive data types as well, and they say they have special support. The reason for that is just like what I said earlier, these are so important. They don't really separate them too much from the language, but they are created using the basic language itself. So apart from this first one, string, you can notice that the other primitive data types have corresponding, the other non-primitive data types have a corresponding primitive data type. So byte has byte, short has short, and integer corresponds with int, long with long, float with float, double with double, boolean with boolean, and character with char. I said char is short for character, so this is the full name, and int is short for integer, and this is the full name integer. And the other noticeable difference is the non-primitive data types start with an uppercase B, S, and so on. And so there is a one-to-one mapping almost between these, between most of the non-primitive data types and the primitive data types, and that leaves this odd one out, string. String doesn't have something that is directly comparable in the primitive data types. Now, what does this all mean? So there are lots of different data types, and the first thing that you have to take out of this is if you have a primitive data type that can do the job, even if there is a non-primitive data type that can do the same job, you have to stick to the primitive data type. So the reason for that is the primitive data types are supported by the language itself, or they are a part of the language itself. The non-primitive data types aren't. They are more complicated, to put it simply, and you should avoid using them if the same job can be done with a primitive data type. So string, on the other hand, is different because it doesn't have a primitive data type that corresponds with it. So feel free to use string without worrying too much. And people use string quite often. But these other primitive data types should be avoided at this stage. They have a purpose, and you will learn those later on. And moving on to what else we can say about these data types. Experience has given us a lot of wisdom, and we don't want to overcomplicate things. That's one of the main themes in programming. So 4 out of the 8 primitive data types I mentioned, they are for whole numbers. So that's a lot for the same sort of information. And what most people do is they use int for whole numbers because int stands for integer. It's self-explanatory, and you get int in most programming languages. So you can just stick to int for when you're storing whole numbers. And there's also 2 primitive data types just for numbers with decimal points. That's float and double. And out of these, you can just stick to double because, again, double is a name that's available across different languages. For example, the C language also has double, and people tend to just stick to double whenever they want to store numbers with a decimal point, and you don't need to think too much beyond that. You might have also noticed there was a thing called Boolean. I said it's for true and false. Now, yes, you can use Boolean. There's nothing wrong in using Boolean, but you might also want to keep in mind that you can use int instead of Boolean to do similar things. So, for example, you can use zero, whole number zero, or integer zero to say something is false, and any non-zero number to say something, say it's true. And in fact, some languages don't really have a built-in Boolean data type. They just use int. With character, we have another interesting issue. It's only for one character. You can't store anything less. You can't store more than one character. So that's very restrictive. Um, Now, sometimes you might know that you might store only one character, but there is a time when you might not want to store any characters at all. So you will have to store some character, and that's, as I said, fairly restrictive. On the other hand, if you use the string data type, which is a non-primitive data type, and I said string is fine um, to use most of the time, you can store zero or more characters, and that's very flexible, and it's a very popular choice for mixed data, in other words, alphanumerical data, or even just plain text data. But we don't use string for numbers that we need to perform calculations on, at least most of the time. So that's the basics of data.